Okay, the next homework question I got was from the review, page 418, question number 9. So question number 9 is asking for the components of a unit vector perpendicular to both of these vectors. So because I want a vector that's perpendicular to two other vectors, I'm going to use the cross product, because that's what the cross product does. It finds a vector that's perpendicular to two other vectors. So I'm going to do the cross of these two given vectors. They didn't name them for me, so I'm just writing them out. This is not going to give me a unit vector, right? This won't be a unit vector. I'll have to worry about that afterwards. So first, just crossing these guys. So I'm going to do 2 times 3 minus 3 times 2. And then I'll do 3 times 1 minus 1 times 3. And then I'll do 1 times 2 minus 2 times 1. And then I'll add these up. All right, so I've got a vector. It's not a unit vector. In order to make it a unit vector, I need to find the magnitude of this thing. So I'm going to find the magnitude and to do that, I'm square rooting the square of each of the components and the sum of the squares of each of the components. And so we've got 18 squared plus 136. I'm just going to go over here. So we get 324 plus that 136 is 460. And it looks like we could simplify 460, so I'm going back over to my calculator. I think maybe I could pull out a 4, and I can, and I get a 115, which I don't think I can pull out any perfect squares from. So I'm going to pull that 4 out. When I square root the 4, I'll get a 2. So this is the same as 2 root 115. All right, so now I have got the magnitude and I've got the vector, so now I can make a unit vector. Remember that to make a unit vector, you do 1 over the magnitude times the vector in question, right? Like that's our formula for a unit vector. So I'm going to do 1 over the magnitude times each of the components of my vector, so 18, negative 10, and negative 16. And so I'm just going to multiply this through. The 2's are going to cancel each time I multiply through. So I'm going to get 9 over root 115, comma, and this is all one vector. And then negative 10 divided by 2, that's negative 5 over root 115. And then negative 16 over 2, that's negative 8 over root 115. All right, then next, I think that was it for that question, yeah? Yeah, that's my final answer there. Okay, so the next question is number 10. Number 10 is asking me, and this question I was asked was just about part A. So the triangle has the vertices A, B, and C, and I want to find the largest angle in the triangle. So to find the angle in the triangle, I'm going to use the dot product. So you might remember that if I have the dot product of two vectors, that's the magnitudes multiplied with the cosine between them. And I want to find the angle. So I'm going to rearrange this guy, right, and move the magnitudes over. So I'm going to be using this formula here. In order to do that, I have to have the vectors for each side of the triangle. Remember that these guys are just points, so I need to find the vectors for each side. So I'm going to do A to B, and so I'm subtracting the components here. So I'm going to get 0 minus 2 is negative 2, and then I'm going to get negative 3 minus 3, so negative 6, and then I'm going to get 4 minus 7, so negative 3. And then I'm going to do B to C and A to C. I'm going to have to worry about matching up the heads, but that's okay. So I'm going to go B to C. So that's 5 minus 0 is 5. 2 minus -3, that's also 5. And -4 minus 4, so -8. And then I'm going to do A to C. Again, if you show your work here for these ones, like I'm skipping the step of showing my subtraction, if you show your work and you make a little slip, then it's easier for me to take off a smaller amount of marks, right? If I can't see where your error is, then I don't know how much you understand. So it's your decision there, how much you want to show me. I'm not actually marking that step. And then A to C, I'm going to, again, subtract my components. Okay, so I've got these vectors. I need to find the angles between them. So when I do that, these two are already set up with the C's at the head, and these two are already set up with the A at the tail. But in order to find like the angle at the corner B, I would have to reverse one of these two vectors and like find B to A, for instance, and then I would multiply each of these by negative. So we'll start with A and C, and then I could actually find angle B as well by using the property that all the angles in the triangle will add up to 180 degrees. So I'm using this formula, and I'm going to start with the corner A. So I'm going to do AB dot with AC. I guess I should put the cos theta on this side. Cos theta equals. And then the magnitude of AB times the magnitude of AC. Okay, so I'm looking at the top vector and the bottom vector. I'm going to dot them together. So I'm multiplying the components and adding them up. So multiplying the x's, add, multiplying the y's, add, multiplying the z's. And then I'm going to put that all over the magnitude of AB. And you could do that off to the side, right? Like if you wanted to come up here and do the magnitude of AB, that's fine. So I would get 4 plus 36 plus 9. So what does that give me? Square root of 49 or 7. And then I could do up here, I'm going to want the magnitude of BC eventually. Not for this particular calculation, but I might as well just do it while I'm here. And so here I'm going to get 25 plus 25 plus 64. So what's that, 114? And then I'll do the magnitude of AC. So 9 plus 1 plus 121. So 131. Okay, so back over here, I'm going to sub in the magnitude of AB is 7 times the magnitude of AC is the square root of 131. And so now in the numerator, I can collect that all to 33. So I've got 33 over 7 root 131. And in order to solve for theta, I'll bring the cos over, and I'm going to do cos inverse of that guy. Oh, okay, so let's see if I can remember this over on Desmos. So we're going to do cos inverse of, I've already forgotten, 33 over 7 root 131. Oops. Okay, so I get an angle of, and I set my Desmos to degrees, so I get 65.7. So it could be the biggest, but probably not. We're going to move on and take a look at these two here are already lined up so that both of the heads of the vectors are at angle C, so I can solve for the angle in between them. I'm going to give it a different name because theta can't be two different things, so I'm going to call it alpha. And here we're using BC dot with AC and over those two magnitudes. It's just a line, sorry. Okay, so if I dot these vectors again, I'm multiplying the matching components. So multiplying the x components, add, multiplying the y components, add, and then multiplying the z components. And then in the denominator, we've already calculated the two magnitudes. And so on top here, I get 10 plus 88 And you can combine and simplify these roots, but that's really not the point of this question, so you don't need to do that work. We're going to bring the cosine over and do cos inverse of this guy. So back over to your calculator. So this time we've got 98 over, I think it was 114, but I'm just going to go back and double check. 114 and 131. So I've got those both, and I get an angle of about 36.7. So that's definitely not the largest angle. I'm looking for the largest angle, 36.7. Oh, I used theta here, sorry. This should be alpha. Okay, so got two of the angles. So to find the third angle in the triangle, that's going to be the angle at corner B. I can just do 180 minus these two that I already have. And I get 77.6. If I wanted to double check my work, I would go through, these guys are all degrees, don't forget your units. I would go through this same process with the dot product divided by the magnitude, but I would have to flip one of these two vectors and make it the opposite. So remember that, like for instance, if I wanted to flip AB, I can't use AB and BC because the head isn't at the same end, right? The head is at B, but then the tail of this guy is at B, so that's not good. But I can use, say, BA and BC. So in order to come up with BA, I need this. I'm going to remember that BA is just the opposite or the negative of AB. And then I'll just multiply that -1 through each of these components. So it'll be 2, 3, or 2, 6, and 3. So I would use this. I can't use this. Can't use these two. So I've got to use these two here if I wanted to check my work. All right, keep those questions coming.